Start recording. I'm going to pin my screen. There we go. Okay, excellent. So we're gonna start where we left off yesterday with the homework. So Jesse, what was the first question under associative law? What was the first question?
Snack.
Can you repeat that? Question 1.
7 plus 3 plus 9.
7. Bless you. 7 plus 2 plus. Sorry about the squeak. So you said 7 plus 2 plus 3.
Plus 3, 7 plus 3 plus 9, sir.
7 plus 3 plus 9. Alright, 1 second.
7 plus 3, sir.
Oh, 7 plus 3 plus 9. Thank you. 7 plus 3 plus 9. So guys, if you have a noisy background, then you can mute your mics. Alright, if you have a noisy background, you please mute your mic. Alright? So 7 plus 3 plus 9. Using the formula, we know that there are 3 terms. The first term is 7, the second term is 3, and the third term is 9. So we're going to say, therefore, A, this is the same thing as saying, this is the same thing, 1 second, this is the same
Sir,
thing.
by the way, the 7 and 3 are in brackets.
Okay, thank you. Right, so you have bracket 7 plus 3, bracket plus 9. This is the same thing as saying bracket A plus B, bracket plus C. Everybody agreed?
Yes.
Now, based on what I gave you as the formula yesterday, I told you you can swap the B with the C, right? And the new formula is going to be A plus C bracket plus B. Don't put another bracket right there. It's going to be A plus C bracket plus B. Now, Jazeel, tell me what this would be now. How would I swap those two numbers and what would I get as my answer? So I'm still going to have the same 7 because the A's are lined up. What would I have after the 7? 7 plus what now?
3.
Are you sure?
Plus.
So the 3 was the B term. Is the B term still in the bracket
Plus
here?
9.
Can you repeat that?
Plus 9, sir.
7 plus 9, right. 7 plus 9. Brackets and plus what?
3.
3. Alright. Now we're going to prove that the answer for both is going to be the same. So let's prove the first one. What would be 7 plus 3?
7 plus 3, let's take 10.
10. So in the first one, we're going to have 10 bracket plus 9 plus 9. Alright. In the second one, what's going to be 7 plus 9?
7 plus 9, 16.
16, excellent. So we're going to have 16 bracket, and we're going to add that to 3. Plus 3 plus 3. And now in both cases, we must get the same answer. So we're going to say, Jazeel, what is 10 plus 9?
19.
19. And what is 16 plus 3?
19.
19. And there you go. That's how you proved this answer. But just to make sure, which law did we observe here? That's the final question. Which law says you can just...
Associative.
Are you sure? You sure?
Yes, sir.
Alright. Because associative deals with grouping numbers. So you can group the numbers separately and still get the same answer. That is associative law. Now let's practice one question from commutative law from the homework. And I want, let's see who is here. I want Emma. Emma, turn on your camera for me. And you're going to help us with one associative law question that you got from homework. I mean, commutative law. Am I here? Hello?
Yes, sir.
Alright, ready? So take me through the steps. So let me pin you. There you go. So take me through the steps now. Remember to have your camera facing on you at all times. So what was a question you got for commutative law? Question 1 from commutative law. What did it say? Hello? Quickly, Emma. Alright, well she's I'm not sure what's happening. Emma, can you hear me?
Yes, sir.
Alright, so what was one of the questions you got for commutative law now? Alright, I'll get back to you, Emma. Just give me a moment. Nicholas, are you there?
Yes, sir.
Alright, your turn now. Tell me one of the questions you got for commutative law. We're going to work it out together.
It was 7 plus 3 plus 9.
No, that one I just worked out, and that was associative law. So I wanted to give you one of the questions you got for commutative law.
8 times 8 times 5.
8 times 8 times 5. Excellent. So this is commutative because we don't see any grouping, right? And we're just going to swap two numbers. Alright. Now let's look at the two formats we could use. This is the first term, this is the second term, and this is the third term. So we can call the first term A, second term B, and the third term C. And we're going to get this formula coming out. We're going to get this formula of A times B times C. Everybody see how I got this formula? Let me just move the camera.
Yes.
Alright. Next thing now, the commutative law states I can swap any two numbers. So I can swap B and C. I can swap B and C. Or I could swap A with any of these two and I still would have the same answer. So for argument's sake, let's swap B and A. Just to prove it. Sorry, not B and A and C. Let's swap A and C. Alright? Nicholas, now, if you swap A and C, what would you get? You would have what multiplied by what now? What was the C value?
Wait, what did you say, sir?
If you swap the position of C and A, what value was C again?
C was 5.
So we're gonna say 5 instead, multiplied by B. What was B? What was B? The second value?
8.
8. And the final value, which we swapped all the way down here, would have been 8 as well. Alright? Now quickly, we're gonna prove both of them. So what is 5 times 8, Nicholas?
5 times 8 is 40.
40. It's gonna be a little bit difficult, don't worry. Alright, what is 8 times 8?
8 times 8 is 64.
64. Now, would you believe me if I said 64 times 5 and 40 times 8 would give us the same answer? Would you believe me?
Yes, sir.
Alright, tell me what the same answer would be then. We're gonna say equal. What's the same?
It would be 320.
64 times 5. Let's ask Jeffrey. Okay, Google. What's 64 times 5?
The answer is 320.
Right, there you go. So the answer is 320. Let me turn up Google for you guys. Alright, 320 and 320. Alright, that was the homework. Now we're going to move on today into a new topic. We're going to talk about why subtraction cannot work in commutative law. Right? Why subtraction cannot work in commutative law. So, head up for me, commutative law. Alright, and we're going to look at why subtraction now cannot work. Alright, now to explain this, I'm going to draw something called a number line. You guys must be familiar with what a number line is, correct?
Yes, sir.
Alright, let me just quickly take attendance. There we go. So a number line, as it suggests, is a line. Is that straight? Yeah, that's extremely straight. Good. That has numbers attached. So let me just quickly draw a number line for you. Okay, Google, tell me a joke.
Why did the school kids eat their homework?
Why?
Because their teacher told them it was a piece of cake.
There you go, guys. This is gonna be a piece of cake. Alright? As Google said. So, we're gonna put 0 right here. Alright? That's our number in the middle. To the right, we're gonna have 1. Continue to 2, 3, 4. You can stop at 4. 2, 3, 4. Now to the left now. Which bright person can tell me what numbers would I have going to the left?
Same numbers.
Negative numbers.
Negative numbers. Okay, Google, tell me another joke.
Why does a duck have tail feathers? To cover its butt quack.
There you go. So we're gonna have negative numbers just as you guys said. So we're gonna have negative, but negative what? Is it negative 0? Negative what?
Negative 1, negative 2.
Negative 1, negative 2, negative 3,
negative 4.
negative 4. Excellent. Alright. And now to explain why subtraction cannot work in commutative law, let's write down one simple question. What would be the answer for 7 minus 2? 7 minus 2. Anybody? What's 7 minus 2?
5, sir.
5. Everybody would have gotten it right. So let's put that 5. Let's put that 5. Okay, Google. Okay, Google. Give them a round of applause. Go. Let's put 5 over here. Let's put. I'm not sure why Google not giving you a round of applause because you do deserve it. You got the question right. So we're gonna put 5. Let's add to 7 now. Let's put 6 and let's add 7. So 6 and 7. So pay attention for me. If you were at the position 7 and you wanted to subtract 5, right? You're going to
Sir,
yes?
I am actually a bit lost. I just came, so I am very lost.
Alright, not to worry. I'm gonna just quickly go over it. So can you recall what we did last class? Everybody turn on your cameras for me. I shouldn't be repeating it. Come on guys, turn your cameras on. There you go. Alright. So, do you recall what we did last class? We talked about commutative law, correct? Where basically we said if I had 5 plus 2 plus 1, I could switch the position of 1 and 2 and say 5 plus 1 plus 2 and the answer would still be the same. So what was 5 plus 2 plus 1, Kasane? That would be 7 plus 1, which is?
Which would be
8. Excellent. And what would be the answer for 5 plus 1 plus 2? 8. So in both cases you realize that the answer was the same. So we're saying now if you were to change the operation from plus to minus, the answer cannot be the same. And we're going to prove it on the number line. Understand? So we haven't started yet, but we're going to start now. So pay attention for me. We're going to prove why when you subtract numbers and then you switch the positions, it won't give the same answer. Let's say I am at position 7 and I subtract 2. You guys say I'm going to go all the way here. Everybody agreed? Minus 2. So put that little circle for me and then put minus 2 at the top. Alright? So that would have given us 5. But let's say that I swap the numbers now. This was A and this was B. This was A and this was B. Instead of saying A minus B, let's try saying B minus A. So what would be B minus A, everybody?
2 minus 7.
2 minus 7. Stay there. Hold on, stay there. We're going to say 2 minus 7 instead. 2 minus 7. So we swap it around. Now, do you guys still think I'm going to get my answer to be the same, which is 5?
No, sir, you're not going to get it back.
Right. So let's look at where we're at. We're at 2. Right? And we're going to subtract 7. So let's extend our number line. Let's extend our number line. And let's go to minus 5. And let's see what our answer would be. Kasanya, everybody look at this for me now. If I am at position 2 and I subtract 5, so I subtract 7. So I go 1, 2, 3, 4, 5, 6. Magically, I go to 7. That means the answer is minus 5. Everybody see that?
Yes, sir.
Is minus 5 and 5 the same number?
No, sir.
That's why subtraction cannot work in commutative law, because you would get a negative and a positive, and those two are not the same. So let me write it down for you. So once you draw this diagram, let me know when you're finished so we can write off the worded answer. So this is B minus A. Alright, here's what you're going to write for me. Alright, let me check if everybody has their camera on still. Alright, Emma, I'll speak with you after, see what the issue is. I don't want to change host. Okay, there you go. There you go. Alright, let's continue now. Anybody have any questions so far?
So, sir, anything that pertains to commutative law, you will never see anything about subtraction because it just won't work.
Right, it doesn't work. Excellent. But not only subtraction, we're going to look at division too. If I divide, would I get the same answer? We're going to see later on. But write this for me now. So, when we subtract, by changing the order of the numbers, when we subtract by changing the order of the numbers, so can I rub this off the board? Everybody, can I rub this off?
Yes, sir.
So,
No, sir. No, sir.
Alright, before I finish though, please ensure that you put a minus 7 to represent this jump. Put a minus 7 right here. There you go. So we started from 2 and we minus 7 to negative 5. Okay. So when we subtract by changing the order of any two numbers or more, the commutative law will not hold true, because the order the numbers are arranged is important. I'm gonna write it on the board, don't worry. So today we're looking at why subtraction cannot work for commutative law and why another operation, I'm not gonna tell you yet, cannot work either. Alright? Alright. Can I rub this off now? Let me take a picture of it if you haven't taken it off. And then I'll just post it in a group later. 1 second. Have to catch wind. And let me take a picture of it. So after class, just remind me to post the picture in the group and I'll post it there. Alright, let's continue now. Let's write off what I just said. Alright. So what I said earlier was that when we subtract, so let me write it in blue. Whenever I write something in blue, it means it's very important. When we subtract, no, that's a bit hard to see. Let me use white instead. Alright. Look at this one now. When we subtract two or more numbers, comma, the order in which, sorry for the squeak, the order in which they are arranged is important. Alright? So, what can we call subtraction? We can therefore say subtraction is non-commutative. We can therefore say subtraction, let me put it in bold too. Subtraction is non-commutative. I'm not sure what's happening here. Huh? What happened to it? Wi-Fi? Still a record.